All right, so let's start by testing for continuity, because in order to be differentiable, we know continuity would be important. So if we're going to check continuity, does f at 5 exist? Yes, it does. All right, so this is to check continuity. F at 5 is going to exist. If I plug that in, that would be negative 25 plus 20 or negative 5. And then we need to do the limit from both sides. So the limit as x approaches 5 from the left of x squared minus 20 is going to give me 25 minus 20, which would be positive 5, and we can stop right there. All right, because it's not going to be continuous. The other limit, if I came from the other direction, as x approached 5 from the right, the opposite of x squared minus 20 would give me negative 5. So it's not going to be continuous, so it has to be A. Okay, if we're not continuous, we can't be differentiable. All right. Question about that. All right, I really like your affirmation today. Okay, even if you're on the right track, you'll get run over if you just sit there. All right, get moving. All right, so today we're going to learn about the power rule to evaluate derivatives. Some of you may have figured it out as you've been working through all the things we've been doing and then how we use derivative rules. This is that derivative shortcut I've been alluding to. And we've kind of talked about it a little bit earlier in the chapter the unit where we talked about we graphed those functions and we graphed their slope graphs, their derivative graphs, and we looked at what happened. So when we plotted f of x equals negative 3x plus 2, the result was a horizontal line. And what was the equation of that line? Do y'all remember? It was a horizontal line. It was negative 3. Okay, it was negative 3. Why did that make sense to us? What would the slope of my line always be? Negative 3. Because a linear function results in a constant slope. Okay. And then next we did x squared and x cubed, and we looked at, we looked at those derivatives. The derivative g prime, when we did that function, it was 2x, and then h prime was 3x squared. Okay. So what I want you to do is to continue on and finish this investigation. All right, so working with the peeps in your group. All right, so let's finish. I think it's got 4 questions.
For like x to the third, it's it equals 3x squared. So it's going to be 4x.
Oh, okay.
So you were halfway there.
So, to be honest, I already know this workout, so the derivative of x.
Yeah.
Because I'm smart. Because I'm awesome.
I have common.
Now I understand it.
Number?
So, that's always my.
Okay, and then flip it over to the next page. It goes on. It's got 4 questions.
What transformation from the parent function reverse reduce the function y times x equation? Upwards. Oh, you see what yeah. Does that change the
Yeah.
How do we know?
That mental math.
Oh, wait, oh, that's basically just yeah.
Okay.
So,
Trust process.
Okay. You did,
it'd be,
Is that change the slope?
I'm just,
Yeah.
cause,
So, what is that?
yeah,
Right?
cause,
Okay.
what, 6 is actually.
Like the 5 times that slope.
No, it's not. The father.
No, like, when you go to high X, what's that triangle called? Oh, bro. What do you call it when you multiply?
X divided by, it's not a vertical transformation. Yes, vertical transformation.
Stretch and shrink.
Is that for
So a
Vertical stretch of 5. Sorry.
Yeah.
It's one for X.
thank you, bro. I cover your mouth, it's okay.
Parker, there's a lanyard on the back of your backpack.
No, there's not.
I'm like,
It's there every day, so I did it.
you don't have to put it on today. I'm just thinking for Friday. Leave it there. That way you know it's there.
I think it will be 10.
Your problem will be you probably won't bring your backpack in, and then
I should.
you should put it in your fanny pack.
Yeah.
Yeah.
If our functionality.
Do y'all have another weekend of shows this weekend for Bright Star?
You don't know? I quit. I dropped Bright Star like a month ago.
Oh, I didn't know.
I don't know, bro.
I was looking for you in the pictures, and I was like, "Where's Parker?"
I did. I felt horrible because I went in because I joined late. I changed everything they did, and then I.
Oh no.
+4 at the end, whatever.
The next show I'm doing is Adam's Family here.
Okay. I like Adam's Family.
It's a great show. I
Be your
love
guest to,
I love it.
in part A, to evaluate J prime.
Physical things that.
Oh, what's the?
Say, where'd you get 36? Yeah.
We were close.
Sorry.
Use math aids to calculate.
So let's think about what's happening.
Answer university.
I understand. Let's think about it.
Yeah.
Oh, you just clicked. That one.
So, that's a really small parameter, right?
What goes in this box here?
Which is.
The last box.
That should just be equal.
Whatever number you're plugging in goes in that last box.
What goes in the other box?
In the middle is your function.
So the slopes are gonna be 5 times as great as the slopes here. So that's why, so multiply by 5, so the derivative is gonna be 5 times as much.
Okay, so that's why.
So yes, x squared becomes.
I did not get that.
Oh my gosh. Exactly.
So.
Maybe I can wait to.
I probably did
It's
it
just
right.
like a little.
Wait, we do the.
Oh, you put that, oh my gosh.
Derivative dy, so the derivative
Okay,
of
you
x
did it
squared equals 2x, right? So the derivative.
Oakley, you make the same faces in here that you do on the volleyball court.
Oh my gosh. I can't help it.
It's so funny. When Oakley does something wrong, she goes, she turns around. It makes me giggle. I'll be here Thursday night.
It feels weird seeing dx over dy because I have 90% of my time doing derivatives.
Yes.
Dx over dt.
Yes. Because you were doing it from a physics perspective. Yep. You were.
Oh, wait.
We'll do some of those. Don't worry. That happens in unit 4, I believe.
No, we're right. No, we're not. Well, yeah, it's right. Plus 4. I just misunderstood what you said. I think that's right. As you knew, you were right. I just can't do that.
Okay, so let's see what's happening. Let's look at the transformations.
Put that back.
There's so much good math happening here.
So, oh, sorry.
Did you learn gears tell you?
Oh, perfect.
To the flip. So, our parent function is going to be something like x.
So it would just
And
be
you were right,
like
parent
2/3. 2/3.
What is happening there?
You drop what?
Okay,
Okay, so if we just not worry about the third for a second. That's
I
second.
don't know what that means before, actually. We're gonna see.
We'll get there.
Let me get draft paper.
Multiply by 1/3. Multiply by 2/3. And drop that.
So we have, let's look at what happens to our slopes as we do these. Okay, so.
Plus 1, right? If I do it. I guess you could just plug it in and see. Give me one cube. That makes sense. You have grammar 1. That would be
So the derivative of that is
5/3.
dy over dz is going to equal 3x squared, right?
I don't know.
So let's, I didn't know it happens. So the slope. So this is just a calculation, okay? So the slopes are really high, it's really steep, and less steep.
You can actually hit answer to fractions.
And then more steep and more steep.
fraction.
So let's
That
look
is
at
backwards.
what's happening to the height
Yeah.
of
That's
this.
right.
derivative function.
Like a little bit of that's right.
And then not as high, and then it goes back to that. So the steepness.
Okay.
So let's look at our steepness as we do this transformation. Down 3 isn't going to do anything. You agree?
Yeah.
So we can just ignore that. And then,
Yeah. What are your options?
so I don't know if this is correct,
Well, yeah.
but maybe we can separate these and do the derivative.
But I'd like to have.
What's the derivative?
Negative.
Yeah.
Just gonna be 4, right?
Yeah, because that'd be.
Yeah, that would be a good one.
I do like X is 0, then
Yeah.
X is 0 would just be 2
Yeah.
I mean, like we said,
Negatives would you go backwards?
sorry,
That'd be great.
no matter.
Would you
Like we said earlier,
I think so.
or do you
if we multiply a parent
do you
by
fractionize
a
it?
number, it's gonna derivative by the same. This is gonna be the derivative of x squared, or the derivative of x cubed
I don't know.
times negative 19 is gonna be
What's going on?
3x squared.
All right, let's take one more minute, then we're gonna consolidate.
And then we have plus 4, right? Which is plus 4. So that's gonna be our negative 4.
I honestly don't know.
I'm not sure
So,
what that is.
like,
So negative 57.
I can consider
Squared.
for like 1 or something.
Yes. And that is our derivative.
What we get.
Is that true? And did we get that right?
I don't know, we're gonna go over it. I wasn't listening.
Oh, let me see this.
How's it in a bad barrel?
It's the derivative of negative 19 x cubed plus 4x minus 3, negative 57x plus 4.
Maybe you can't solve.
Did we get that right? Please,
Yes.
please, please. Yes! I'm
not gonna lie though, I think I was crazy in that quiz.
He's in his academic comeback era.
Solomon was here, he'd be there too.
You have to tell me.
All right, so let's kind of consolidate what we found. Okay, you guys have been doing a good job. Lots of good math conversation going on. Makes my heart happy. All right, so let's take a look at 2B. kind of consolidate all of this, bring it to a point. So what do you think would be the derivative of x to the fourth? 4x to the third. I concur. What about the derivative of x to the 50th?
50x to the 49.
All right. Now, what are we doing when we're doing this process? What pattern are you following?
The derivative of x to the n equals nx to the n minus 1.
Oh, I mean, we just went all the way there.
Yeah.
Okay, we put the we put the exponent in front, and then subtract 1 from the exponent.
That's what I did.
Yeah. Congratulations, that's the power rule. Okay, that's what that is. And so that's what's nice. Parker went there, n times x to the n minus 1. That's the formal, all right, the formal expression of the power rule, but that's exactly what it is. Okay, so that being said, let's talk about what happens when we start transforming functions. Okay, because not all functions are just one term, right? Things happen, things change. And so let's see what we get. All right, so now let's consider some transformations. What transformation occurred to produce x squared plus 6? All right, we took it up 6, so it was a vertical translation. Okay. What do you think the derivative is going to be? 2x, okay? Why do you think that? Yeah, does the slope change with that plus 6 on the end? I just scooted it up. My function didn't really change. The slopes didn't change. Okay. So one of the things that we can say is this, is that if that vertical shifts don't change the derivative. Okay, so if I scoot something up or down by a constant, it's not going to change anything. Okay. So then what's our transformation there on part C when I have 5x squared? It's a vertical stretch, right? By a factor of 5. Is that going to change my slope? Yeah, it is, okay, because there's extra out there. So what do you think dy dx will be? All right, it should be 10x, okay? All right, and the reason that happens is because the graph is steeper at every point. All right, and so if we put that into some formal mathematical language, right? If we have f of x is equal to, oh, what's a good way to say that? Let's say it this way, k times g of x. Oh, that looks like composition, hang on. Let's do that. So k times g of x, then f prime of x is the same as k times g prime at x. Okay, so it's just a constant, that constant stays there, right? It makes my slopes steeper, so my derivative is going to be steeper. All right, that being said, let's move into 4. Okay, so here we've got multiple functions put together. All right, what's your best guess for j prime? Negative 57, x squared, 4. All right, plus 4. And here's why, all right? if j of x is equal to multiple functions added together, let's say f of x plus or minus g of x, then j prime is just those individual derivatives added together, okay? So if we wanted to evaluate j prime at 6, we would just plug in 6 into our formula. So negative 57 times 6 squared plus 4. What'd y'all get?
Something.
It's a big number. Yeah, negative 2048. And if you check that with Math 8 on your calculator, that is what you're going to get. Okay? So just getting used to using the power rule. Okay? Now, that being said, all right, let's look at number 2. Let's generalize the power rule. Let's see if we can apply it to lots of different types of power functions. Okay? So here, I've given you some that are, all right, done for you, so you can see those, right? And then we get down to some interesting exponents, okay? So if we follow our rule, a while ago you guys said that we put the exponent in front. If there's a coefficient there, what do we do with that exponent? We multiply, okay, so that doesn't go away. We put the exponent in front, and I like to say multiply by any coefficient. Okay, and then we reduce our exponent by 1. So this is where we just have to be careful. Okay, we just have to be careful. So with our subtraction, so if I look at the first one, f of x, x to the 2/3, what would my coefficient become? 2/3. And then I'm going to subtract 1 from that exponent. What's 2/3 minus 1 or minus 3/3? Negative 1/3. Okay. Plus, then we get to the second one. There's a coefficient there, right? So we've changed the steepness. So I'm going to take my exponent times the coefficient. So 1/3 times 3. That's just 1x. I'm going to subtract 1 from the exponent. So 1/3 minus 3/3 or minus 1 is negative 2/3. That last number, that minus 8, is just that vertical translation. Do we care about that? Nope. I mean, we care, but it doesn't affect our derivative. You're correct. We do care, but not in terms of the derivative. Okay? Well, we don't want anybody to feel left out. All right, let's look at the second one. All right, so all these individual functions, let's walk through this. 8x to the 5th, what would that give me? 40x to the 4th, good. Negative 7x to the 3rd. Negative 21x squared, good. Okay. What about 6x squared? 12x. And negative 8x. Minus 8. Okay. The 2 is just that vertical translation, not that interested in what's happening with it for the derivative. Okay. Negative exponents seem to be where we get the most confused because we make minor arithmetic errors, but the process is the same. Okay. 3x to the negative 3rd. What's your new coefficient going to be? Negative 9. Negative 3 minus 1 makes it negative 4. It's getting more negative because we're subtracting. Okay. 8x to the negative 2. Negative 16 to the negative 3. Good. Okay. Negative 7x. Negative 7. The plus 2 doesn't matter. Okay. Now, because it's that vertical shift. So does our rule, okay, that we wrote explain why the derivative of a constant is 0? Think about that. Why do you say yes, Gareth?
Because you can think of the constant as being constant times x to the 0th power.
Oh. Okay. We could think about it as being the constant to the 0th power, right? And if we followed our pattern and we multiplied, I get 0 times x to the negative 1. But what's 0 times anything? It's 0. Okay, so our rule does make sense. Even though we know that comes from that vertical translation, mathematically it still makes sense as to why it works. Okay, because anything to the 0 power is actually what? 1. Yeah, it's actually 1. So 6, all right, is the same thing as 6 times 1, which is the same thing as 6 times x to the 0. So when I take a derivative, this is f of x. F prime of x is still going to equal 0. Okay, so anytime you take the derivative of a constant, it's 0. Ooh, I'm so excited. That's the best part, y'all. Now we can just do all kinds of stuff. All right, I'm so excited. All right, this is going to make derivatives so much easier. We just have to be careful. Okay. All righty, so flip over to that next page for me. Let's formalize it a little bit. Okay. So the power rule, we're going to put it in formal mathematical notation. Okay, this would be something good to go on your formula sheet. If f of x is equal to x to the n, f prime of x is n times x to the n minus 1. Okay, we bring that exponent in front, multiply it, and then subtract 1 from the exponent. Oh, I spilled my water this morning. Okay. Now, one of the things we have to be careful about is remembering when can I use the power rule. Well, I can only use it when I have a power function. What's a power function? Yeah, it's anything x to some kind of power, okay? N can be an integer. It can be negative. It can be a fraction, right? Those all still represent power functions. So x to some power is a power function, right? So we're trying to figure out which of the things below are actually power functions that I could use this rule on, okay? Because it only works on power functions. Take a second look through this. Which ones are going to work? Okay, so it's all about knowing when you can use it. All right. Madeline, give me one that's a power function. Yep, y equals x to the third. I agree. Jawak, is there another one? Yeah, lay it on me.
Y equals
2 to the x. All right, is x the base in that one? No, it's the exponent, so I can't use that one. Okay, that's an easy mistake to make, right? That's an exponential function. Difference between an exponential and a power function. All right, good job. All right, Himmel, give me one.
Alright, you got it.
Absolute value of x to the third plus 8.
Nope, can't use it on absolute value. Okay, can't use it on absolute value, right? Absolute value changes everything. Absolute value becomes a piecewise function, okay? And then eventually we would use the power rule, but we're not going to treat it like a normal power function, okay? All right, something else. Negative x to the fifth over 2. Yep, this is the same thing as negative 1/2 x to the fifth. Very definitely a power function. Okay. Anything else?
Y equals the fourth root of x to the fifth.
Yes. Okay, this is the same thing as x to the 5 over 4. So that's a fractional power. So that works. Square root of x is going to work. Yep. Three x minus 5. That's a linear function. That's going to work. Yeah, negative 3 over x third, because I could write that negative 3x to the negative 3. Okay, so if I can rewrite it as an integer where even if it's negative, that's a power function. Okay, so recognizing when you can use a power function. All right, so that's important. We got to know when we can use the rule. All right, because it doesn't apply to everything. Okay, unfortunately. All right, and that's when derivatives get tough. But this is the first step. Okay, so let's take a second and let's mess with this one. Y'all want to try that one?
Yes.
Yes, go for it. Okay. Remember, those are fractional coefficients. All right. See if you can find dy dx. Bear's been living for today since August the 6th. They are easing, which is good news. They will get harder. They're going to be easy today and tomorrow. How about that?
Can you just give us the easy ones from now on?
I wish.
Did you say we have a quiz on Thursday?
You do. It's over 2.4, which is the differentiability stuff. It's very short. And then you have the rest of the block to work on what you need to work on. I think it's only 5 questions.
Oh.
So I'm gonna make it 20.
You didn't make a 20 yesterday. All right, are we ready? Let's check this bad boy. Okay. What's my coefficient that's already there? Negative 1/5. Okay. And so I'm going to multiply that coefficient by my exponent. So what will it give me?
-1.
Negative 1. X is going to go to what power?
4.
The 4th. Okay. 3/4 times 4 would give me 3. And x is going to go to what power? Third. Negative 5 over 2 times my exponent, which is 2. Negative 5. X to what power?
1.
1. And then 2/3 x times 1. 2/3 x to the 0 power, so the x goes away. Okay? What do you think? Okay? Let's look at this one. Okay? Before I do this one, there are some things I'm going to fix because right now it doesn't look very friendly. Okay? It doesn't look x to a power, x to a power, x to a power. Okay? So, but can we rewrite that square root? Can I rewrite that over x to the third? And the answer is yes. Okay? So let's rewrite before we start. So that would give me f of x is the same thing as square root of x would be x to what power? The 1/2. Okay? Minus 2x to the negative 3 plus 5x. Now everything's in the right form. We can follow our power rule process. Okay, so 3 times 1/2. 3/2. X to what power? Negative 1/2. Okay. Negative 2 times a negative 3. A positive 6. X to what power? Negative 4. And then 5 times 1, we'll give them with just a 5. Now, on a multiple choice, they're probably going to write your answer like this. 3 over 2 square roots of x plus 6 over x to the 4th plus 5, okay? Why do you think they might do that on a multiple choice? I know. They would probably do it because that's how the problem started, okay? Mathematically, it's not good to leave negative. It's called a mathematical convention. I had to think of the right word. It's like a meeting. That's what I kept thinking. It's called a mathematical convention that we don't leave negative exponents in a problem, okay? AP will leave them sometimes and not others, okay? In a free response, you can leave them. In a multiple choice, you never quite know how they're going to put the answer. All right, so just know that, okay? You may get a professor in college who will, do minus 20 if you don't do that. So it's just one of those things, right? You'll have to see what they prefer, okay? All right, so let's look at number 7. Let's kind of expand what we're doing a little bit and talk about the different types of problems. So it starts out on 7 as just saying, hey, find dp dt. Okay, so they change the variables around, right? P is my dependent variable, T is my independent variable, but we're just finding a derivative like we've always done, or like we've been doing today. Okay, and so if we find that dp dt, okay, what's going to be your first piece? 3t squared. All right, what about your second piece? 12t, and then the next piece, minus 5/3, and then derivative of 16 would just be 0, because that's a horizontal line, its slope would be 0, okay? So now it asks me to find the equation of the line tangent to P at t equals 3. This derivative is the same thing as what? Slope of the tangent, okay? And to write an equation of a line, we need a point and we need a slope, okay? Well, now I have a formula for the point and I have a formula for the slope. What t value do they want me to consider? 3, okay? So we're going to do two things. We're going to do p at 3, so we get our ordered pair, and we're going to do dp dt, okay, at 3. So that we can get those two values that we need, all right? So p at 3, 3 cubed plus 6 times 3 squared minus 5/3 times 3 plus 16. Now, this isn't everybody's favorite kind of arithmetic, but it's not undoable, all right? 3 to the third is how much? 27. 3 squared is 9 times 6 is 54. 5/3 times 3, 5, and then plus 16. Okay, now you can go through this any way you want to, but here's what I see. 54 and 16 is 70. I take away 5, that's 65. And then 27 and 65 would be 92. Okay, that's how I would mental math it right there. Okay. So my ordered pair, let's get this over, equals 92. So my ordered pair is 3, 92. Okay. The next thing I need is my slope. So we're going to plug that into that derivative we just found. So 3 times 3 squared plus 12 times 3 minus 5/3. This one's going to take a little bit more work without a calculator because there's going to be a fraction. All right. It's not the end of the world. 9 times 3 would give me 27 plus 36 minus 5/3. Okay. 27 and 36 is going to be 63 minus 5/3. Now, in order to put those together, I got to make that 63 something out of 3. So multiply it by 3. 189 over 3 minus 5 out of 3. And I get 184 over 3. Now, that's not a beautiful slope, all right? In fact, it's quite gross, all right? But here's the good deal. Those are the only two things I need to write the equation of my tangent, okay? So when I give your quizzes back here in a second, some of y'all are going to be mad at yourself, all right? You have to start it as y equals, all right? What always comes first? Slope, 184 over 3. What comes first in the parenthesis? x. Opposite of the x value in my point, same y value. Okay? And 7 times 7 is 49, not 14. Okay? We all make those mistakes. Okay? I make them more than anybody else, so. Okay? So that's the way they could ask me a question about a tangent line, but I can use the power rule to do it. When they do that, typically the numbers are nicer. All right, I just gave you one with some nasty numbers there. Okay, let's look at a few more different types of examples that they could ask me. Okay, take a look at this one. Does the curve y equals x to the fourth minus 2x squared plus 2 have any horizontal tangents? If so, where? Whew. So let's just kind of dive into that. What does that mean? If I have a horizontal tangent, it's a horizontal line, which means my slope would be what? 0. In other words, I'm looking for where is the derivative equal to 0. Okay? That's the question this is asking me, is where is the derivative equal to 0? Okay? Well, the first thing I'm going to need is the derivative, right? What's going to be y prime in this problem? Four x to the third minus 4x, okay? So we're going to take that derivative and we're going to set it equal to 0. Now, we got to solve this equation, right? What would you do? Take out a 4x, all right? That leaves me with an x squared minus 1, okay? And so then what are we going to get? What's x going to equal? Yeah, 0, 1, and negative 1, okay? You could set 4x equal to 0, x squared minus 1 equal to 0. So we get 3 spots, okay? So does it have horizontal tangents? Yeah, in fact, it's got 3 of them, all right? Where x is equal to 0, where x is equal to 1, and where x is equal to negative 1. Now, typically on these problems, they will specify, all right, if they want the complete ordered pair, all right? So it may say find the x values where there is a horizontal tangent. Or if it says find the points, we'd want the y values that match. How would I get the y values that match? Plug it into the original function. Okay, so you just need to read the question to know what it's asking you. Okay? All right. See what you can do with 9. All right, so I'm just trying to show you lots of different ways they can ask you these questions. How do I keep accidentally putting Himmel and Samuel together?
That's what I'm saying.
I'm not even part of the
I'm
conversation.
not even being like this. You need to talk about teach a 12-year-old to
What?
Sam just needs to sit by himself.
Honestly, no, you need to sit with Solomon. You need to sit with Solomon.
You need to weigh
They
in.
fight.
Put Sam
Exactly.
and Salt.
You need
They
to
fight.
weigh in on the random. Truly random is not working.
It is not. Because that's what I've been doing. And I'm just like, oh my gosh, they end up together all the time.
I'm not having a conversation with them.
Okay.
Okay, so let's talk about what they're asking me for. All right. If I want an equation of a line perpendicular to the tangent, what am I really looking for? Normal. The normal. Okay. I'm looking for the normal line. So let's start by getting the slope of the tangent. Okay. The slope of the tangent is the same thing as the derivative. All right, which would give me 3x squared minus 3. What's the x value we want to evaluate that at? At 2. Okay, so I'm going to evaluate my derivative at x equals 2. There's another way to write that notation. Okay, they do that bar and then x equals 2. So I want to show you all of those. 3 times 2 squared minus 3. So 12 minus 3, which is 9. Okay, and so then what's going to be the slope of my perpendicular? Negative 1 over 9. And now we're just going to write our equation. Y equals negative 1 over 9, x minus 2, and then plus 3 using that point that they gave me. Okay, so too terrible? Nah. Okay, now that we know the power rule, life's going to be exponentially greater. But I only got so much, y'all. They don't give math teachers a lot of good puns. Okay, so let's talk about derivative rules, okay? This day, the only one we've discussed is this one, all right? We talked about the power rule. We've written that down multiple times, but if I take, let's say, h of x equal to f of x plus or minus g of x, if I've got multiple functions, to get my derivative, we just take our individual derivatives and we add or subtract them together, okay? Does it say anything about multiplication? Nope. Does it say anything about division? No. Okay. So sometimes we have to get creative in a derivative to get it into our function, into a form where we can use the power rule. Okay, so let me show you a couple. Okay, let me show you a couple. Because we're going to eventually learn rules for multiplication and for division and all that good stuff. In fact, that's what we're going to do tomorrow. But I'm pretty sure that's tomorrow. Anyway, like I write my lessons a week or so in advance and I can't remember. But today we've just got the power rule. It's the only tool in our toolbox. Okay, so sometimes we have to get creative. All right. So let's look at this one. All right, first of all, there's way too many letters in that problem. Okay, you feel it? Yeah, we missed the math, it's just numbers. So h of t, I have 1/2 gt squared plus vt plus k. All right, who is the independent variable in that problem? T. All right, t, it's whatever is in parentheses, okay, in the beginning. So that's like my x, okay? Everything else is considered like a constant, all right? But it's just a variable constant that we might not know, all right? So if I'm going to do h prime at t, I'm going to take the exponent of t times the coefficient. Well, the coefficient is 1/2 g. So what is 1/2 g times 2? It's just g, okay? We're going to take t down a power, so it's going to be t to the first, okay? On the second term, t is my variable, all right? My exponent is 1, so 1 times my coefficient is v. What's 1 times v? V. T is going to reduce by 1, t to the 0 would disappear, okay? K is a constant. What's the derivative of any constant? 0, and that's my derivative, okay? So you just have to be careful and note what is the actual variable in that problem when they give you all that many letters, okay? All right, let's look at the second one. So I have y equals 3x to the 5th plus 2x minus 7 all over x squared. That's a quotient, all right? We don't know how to do a quotient yet, so could I rewrite it so that it's not a quotient? Yeah, we can. What should I do?
1 times, or 1 over x squared, right?
Yeah, we're just going to divide everything by 1 over x squared. We're going to divide everything by x squared. Okay? Because when I have a monomial on the bottom, we can divide everything on the top by that denominator. Okay? So, that being said, let's rewrite y. Y is going to be 3x to the 5th. If I divide it by x squared, 2x divided by x squared minus 7 over x squared. That's what division by a monomial means. All right? Can I simplify that? Sure enough. So y is going to be 3x to what power? The third. The next one's going to be what? 2 over x, but I want it in power function form. So 2x to the -1. And the second one, nothing reduces, so I'm just going to bring that up. -7x to the -2. Okay? So I'm going to rewrite it in power function form so that I can use my power rule. Okay? So lots of algebra right there. Okay? So now do your derivative. Okay? Y prime. What are you whatting me about? Just tell me. So 2x over x squared, it would reduce to 2 over x because the biggest one's on the bottom.
Yeah.
Yeah? And so I just pulled it up.
Oh, now you're doing the.
Yep. Yep, now I'm doing the derivative. Okay, so here we go. 3 times 3x cubed will give me 9x squared minus 2x to the -2 plus 14x to the -3. Okay? So subtract 1 to that exponent.
And then you put that.
You could rewrite it. I'm not going to make you, but on a multiple choice, they might.
And if you did, it would be -2 over
X squared, plus 14 over x cubed. Yep. Yep. Okay, let's do one more creative one. I like the creative ones. Okay, because I'm pulling out some AP ones. I know.
all day. Barely even been a day.
All right, so find W prime. Okay, of y, given that W of y is y minus 4 times 2y plus y squared. Okay, that is not a power function yet. What's going on with it? It's been multiplied. So how could I make it a power function? Multiply it out. Okay, have at it.
Involuntary.
Just you reading it made me laugh.
Yeah.
Why?
Why?
Why am I doing this?
Good.
I'm kidding. I'm doing this.
I'm convinced you're trying to confuse us by changing the variable name.
I think I did it. I feel like I did that way too quickly.
They do that a lot on the AP exam.
Am I bugging? Are we literally bugging for real?
Oh, I just noticed you got 2 different shoes on. Okay.
Yeah, it's really weird walking. I didn't even walk around, and now I wish I would not have worn this.
I need to go out to my car and put on some wacky socks.
Literally, Laura, you have on matching socks.
I know.
Hey, you have to get that extra
No, it was
credit.
on purpose.
You have to get that extra credit from Miss Edwards.
No, it was on purpose because, like, in the tornado, I like found 2 matching socks.
Because they usually never match.
I was trying to come up with
By nature, so no reason to, mess up a good thing. All right, so let's take a look. So let's distribute, combine all of our terms. It's going to give me 2y squared plus y cubed minus 8y minus 4y squared. Simplify that a little bit. That's going to give me negative 2y squared plus y cubed minus 8y. Now we're ready to take a derivative. So W prime of y. Negative 4y plus 3y squared minus 8. How'd you do?
Well,
I didn't do that one because I why'd you to death, apparently. Okay. All right. So AP likes straightforward problems, but then they like things like what comes next.
Oh gosh.
All right. And it's a table. There will be a tabular derivative somewhere on your test, okay? Typically multiple ones, all right? And so let's take a look at this one. Okay. So it wants me to find the value of k given the following information. So it's giving me an x value of 16, an f prime value at 16 of 4/3, a g prime value at 16 of -10, and an h prime at 16 value of pi. Okay, so it's giving me some derivatives, all right? So here's what we're going to do. We're going to take a derivative, okay, h prime at x, all right? Now, the thing to remember is that when we start this function, all right, there's a lot going on here, okay? There's a lot going on. First of all, this is a coefficient of f of x, all right? So if I was doing the derivative of f of x, I would multiply it by that coefficient, all right? So I'm going to keep that coefficient 3k f prime at x, all right? Really, the coefficient doesn't change, all right? But f, I would take its derivative. Now, for the second term, remember that that's the same thing as minus 8x to the 1/2, okay? And so if I take its derivative, what's that going to give me? All right, minus 4x to the -1/2. And then the last piece of that function is a g of x. Well, its derivative is just g prime because I don't know what the function is. They didn't tell me. Okay. Now what we want to do is to evaluate at those x values that we know. And I'm going to take this probably an extra step, all right, just so you can see what I'm doing. The x value I'm going to plug in is 16. Everywhere I have an x. So I have h prime at 16 equals 3k times f prime at 16 minus 4 times 16 to the -1/2 plus g prime at 16. Right? So let me stop there. Okay? The x value we're considering is 16. The reason we know is because it's the only x value in the table. Okay? Now, let's do a little simplification. How much is h prime at 16? It's pi. Equals 3k times how much is f prime at 16? 4/3. Minus 4 times. Now, interesting. 16 to the -1/2. All right, so that's 1 over the square root of 16. How much is the square root of 16? 4. And then g prime at 16 was how much? -10. Okay? Is everybody with me so far? Just simplifying a little step at a time. Okay? All right, let's keep going. So I get pi equals, those 3's are going to cancel, so I get 4k. -4 times 1/4 is going to be a -1, and a -10 gives me a -11. Right? This problem asked me to find k, so I'm getting closer. All right, I'm solving an equation. What would I do? Move the 11 over, and so I would have them go over here so I got more space. 4k would equal pi plus 11, and then what would we do? We divide by 4. Now, this is an exact answer. I have no idea what that number is, but it's exact. Okay, pi plus 11 divided by 4. You will do tabular derivatives. There's some in your practice tonight. Okay, you got to practice those. Okay, what do you think? That one's a little bit tougher. Okay. I want to get to a couple of things, so give me just a second, because we're not going to get to all of these today. I put a lot of extra in here. Okay. Let's talk about how we would do 14, but we won't complete it. Okay. So it says determine where, if any, the tangent line to f of x equals x cubed minus 5x squared plus x is parallel to the line y equals negative 2x plus 23. Okay, what are we going to need to do first? Take the derivative because we're talking about the tangent line. Okay, so we're going to need f prime at x. All right. I want it to be parallel to this line. What does that mean has to be true? Their slopes have to be equal, okay? So their slopes have to be equal. What's the slope of that line? It's negative 2. So I'm looking for where is my derivative equal to negative 2. All right, and that's how I would solve it. I'd take the derivative, set it equal to negative 2. All right, so I just want to talk through it. Yeah.
Wait, so all these years we've been working with like lines and stuff, we've been secretly taking derivatives.
Yes, you just didn't know. They do. They start you awfully young. All right. Let's look at the next one. This is a tabular derivative. I want to do this one because you will see one like this when we have our first quiz over derivative like this. But that'll be next week. Okay. I know, it feels like forever, right? All right. So here we go. Notice what icon is by B. Okay. It's a calculator question. Part of it, you're going to need the calculator for. Okay. Because if we look, it says let h, here's my table for f of x, but here's the function for h of x. Look at that bad boy. He's not a power function. We don't know how to do him yet. Okay? We will. We'll be able to do him by hand, but we're not quite ready. Okay? So let's look at what we want to do. So if I want to find m prime at 3, okay, I just need to take the derivative of my two functions at 3. Okay? Well, f prime at 3 is going to come from the table. Just be careful. What is f prime at 3? It's 8. Okay? To do h prime at 3, this is where I need my calculator. I got to math 8 that bad boy. Okay? So that's why it's a calculator question. Okay? We're going to math 8, do a numerical derivative, all right, and plug in 3. Okay, did you get something weird like negative 2.061? Second ln. Okay, and I got 5.93. Ooh, I'm too far. Did I do it right? Double check me, because that's an old answer. It could have been wrong. Okay. We okay with that one? Okay. So using a table and using your numerical derivative. All right. Last one. All right. Let's look at this one. Okay. It says the graph of the linear functions f and g are shown above. If h of x is equal to f of x plus g of x, then what's h prime equal to? Okay. What's h prime equal to? Well, the first thing I need to notice is that both of those functions are linear. So what does that mean their derivative is going to be? It's going to be a constant slope. Okay. So if I'm looking for h prime at x, I need the slope of f plus the slope of g. That's all that says. Okay, again, just being able to interpret what the question wants from you. Okay, so what is the slope of f? 1/2. And then the slope of g is -1. And so, excuse me, my overall slope is -1/2. Okay. Now, 17 is a really good question. I want to do it tomorrow when we start class. Okay. But I just wanted to give you a minute to get your wrap up done. This is your lesson practice. Here are a few in your text, page 129, 130, 3, 5, 7, 9, 37, and 39. And then there is a packet back there of some just really good table questions. The ones in the text are kind of your basic, just practice a derivative using the power rule. 37 and 39 probably ask you to write a tangent and normal line, okay? But then that 2.6 packet has some really, really good problems in that, okay? Click your link on Google Classroom and do your wrap up. Okay, y'all are doing pretty good on those.
Is that packet on Google Classroom?
It is, yes. There's some paper copies back there if you want one. It's got 9 questions. One is a free response, which is really good. Most of them are multiple choice, except for the last 2 on that packet. No, on the packet. And I've posted the key to the packet, but I'll post your book problems too.